Welcome back. This unit is basically all about loops. We learned in some previous videos about while loops. We'll learn about for loops a little bit later. Let's get some more practice with while loops with this little warm-up program. It says write a program sum x, y that prompts the user to enter two integers. I'm calling those x and y, and then prints a summation of all the values in the range x to y. So this is going to be basically sum 100, which we use to kind of demonstrate the idea of a while loop. But we're going to see a couple of interesting techniques, if you will. For one thing, we're going to be using user input to kind of modify our program. So we'll see how that can be used in combination with our loops. Additionally, this x and y kind of represent like a starting and stopping point. And so we're going to get to see what is the effective starting point for our loop and what is the effective stopping point. So without further ado, let's get into coding. I've got IntelliJ pulled up. I'm going to make a new project. You could consider modifying sum 100. Let's just start from scratch. I'm going to go to File, New Project. We'll go Next, Next. And I'm already in my Principles folder, so I'm going to create sum xy. I'm going to expand my project folder, right-click on the SRC, make a new Java class. I'm calling that sum xy. Right, I'm going to plug in my main method. And our prompt is telling us that we're getting user input. So we know we're going to be using scanner. Let's do that. I'm going to jump straight to step 2, which is creating my scanner variable. So I'm going to create a scanner, which I'm calling input, and that is a new scanner that reads from system.in, the keyboard. Notice that by just jumping straight to step 2, that IntelliJ automatically imported. I used the IntelliSense to kind of autocomplete what I was wanting to do. But I've already done step 1, which is import. Step 2, which is constructing my scanner object. We're ready for step 3, which is prompting the user. And this is one of those where I just want to simply ask for x, y. So I would kind of recommend, giving them a heads up on what the program even does. Something like this program finds the summation of the values in the range x comma y, right? So this syntax here meaning inclusive for x, inclusive for y. X is part of the summation, y is part of the summation. So this program finds the summation of all the values in the range x comma y. So I'm prompting them. I did it after the scanner. Realistically, you could do it up front. It's such a minute thing, it doesn't matter that much. But by doing that, I can simply ask, please enter a value for x. Okay. Again, you're programming it, you know what the program does. So if you just cover that up and wrote, please enter a value for x, you know what that is for the time being. But if you were like to come back maybe months later, you're like, what does this program even do? So being clear with the user is important because it means that we can do easy statements like this. Let's get that, right? I'm going to get an integer, and we'll take our scanner that we constructed on line 9, and I'll tell that to get next int. That's my value for x. I'm then going to prompt the user. And you could have copied and pasted that like an adult. But we're going to use that exact same scanner. Notice I'm not creating a new scanner to get that value. All right, so this is the user input part. I've brought in scanner, I prompted them, I've gotten x and y. I'm actually ready to start looping. Okay, our loop syntax is simply put that. Right, I have a while loop here. That is all the syntax is ultimately required. We, of course, are going to have some type of Boolean value inside the parentheses here, a condition. But one of the main things I kind of want to hone in on with this project is this is, of course, going to be very similar to sum 100, except we're basically modifying where we start and where we stop. Where I'm starting is x. So why don't I do this? Why don't I open sum 100 real fast? And let's maybe bring back our condition. I'm gonna take some of this fluff out so we're left with just the meat. Okay, so this was sum 100, right? We had some type of variable to track our summation, our total. We had some type of number, which is the next number that I want to add. And then we said while that number is less than 100. Okay, we kept adding that number to our sum, saving it back into sum, and then we would increase our number by 1. So in the next iteration, I would be adding a new number to my sum, the next number in the sequence. What I'm trying to identify with sum xy is basically what controls where I start and what controls where I stop. Okay, this is my sum. It has really no control. This is ultimately my final output. It has no control of where I start and where I stop. However, this number, this effectively is my starting point, right? This is the first number that I want to add to my sum. What controls when we stop? Well, inside the body, I'm just updating my sum, and I'm just updating my number. So the next one, so what I'm getting at is the condition is ultimately what controls where I stop. So this is where I start, this is where I stop. I basically want to take this and kind of translate it into my sum xy. So I'm back in sum xy. We've gotten our starting point, x. We've gotten our stopping point, which is y. I'm going to need a couple of variables. I'm going to need a variable to track my total, my sum, my summation. That effectively is 0. Before we start, I have nothing, right? At this moment, I have nothing with my sum. I basically already have a starting point. It's x, right? So I have x. There's really no reason to do any type of new variable. Now, I have a condition here that I need to incorporate y. So we're going to kind of loop over this range starting at x. My x is already in use. I've already declared my starting point. I need to use y as my stopping point. So because this is inclusive, we're going to say while x is less than or equal to y. All right, x is going to be my starting point. Maybe we should put some stuff behind this. Let's consider an example. Say you want to figure out what is the summation of 5 to 7. Super simple, right? We're talking 5 plus 6 plus 7 should ultimately give us 18. I hope I did that right. So x is going to start out as 5. And what we're going to do over the course of this loop is increase it. It is going to approach y. With each iteration, what I'm going to do is update my sum. I want it to be what it currently is plus x, right? Initially, sum is 0, so we're going to say 0 plus 5, using this example. And so the new total here is 5, which I am then saving back into sum. My sum so far is 5. Now, the next time I come back through this loop, on the next iteration, I want x to be 6. I want it to go to the next number. So I'm going to update x and say x is what it currently is plus 1. I'm just going to increase it by 1. Right? So after we add 5 to our sum, x is now 6. I save that back in. We would ask, is 6 less than or equal to 7? We'd have another iteration where we take our sum, which keep in mind at this moment is now 5, plus 6 is 11. I'm going to save that 11 back in. We would increase x to 7. We would ask, is 7 less than or equal to 7? It is. We would take our sum, which is now 11, add 7 to it, giving us 18. Save that back in. Increase x to 8. Ask, is 8 less than or equal to 7? At which point that would be false. Okay. After the loop is over, I should have a summation. It should be stored in sum. So I can print that off. So why don't we demonstrate this with our test case, right? Our 5 to 7 test case. I'm going to right click in free space and tell it to run. And then we need a value for x, I'm going to do 5. And we need a value for y, I'm going to do 7. And we see our summation there is 18. So what's nice about using user input is that we ultimately make a program that's way more versatile than sum 100. I could still accomplish sum 100 with this, right? Initially, sum 100 was starting at 1 and going through 100, right? That's what we would get with sum 100. But the big takeaway here is effectively what controls our starting point, what controls our stopping point. Right? I could have brought in another variable that represents my starting point, right? I could have made number equal to x, but x already exists, and you could still take this route if you don't want to modify x. Like if you wanted to list what x was after the fact, right? The problem with taking x and modifying it in this loop is that it loses its original value. So if I'm down here at the bottom of the loop and say I wanted to annotate this to say what the number range is, I wanted to display that number range 5 to 7. Well, I've already modified x, so I lost that. However, if we took x and saved it into a variable and then used that variable, right? I replaced these x's with number. X would still remain intact. It would still be the original value, and number would be the one that's updating each iteration. But x is effectively my starting point, and this is what controls where I stop. That's our important takeaway. Okay. Let's hop back to our slides because there's a couple of things. I want to talk about counter variables. I want to talk about assignment operators, and I think we'll code factorial and hit our recap in a different video. So loops often need to track their iterations. That is the number of times the body of the loop executes. A variable can be used to track the number of iterations. We haven't really formally talked about this word, but an iteration is a single execution of the loop. The idea is that we're going to initialize the variable with a value, and each iteration simply increase the variable by 1. That's what we're doing with x in our program. That's what we did with number in sum 100. This is going to loop 10 times. Right, we're starting at 0. We're going up to 10, not actually 10. Right, as long as count is less than 10. We're going to print off hello world and increase our count by 1. A variable that is used to track the number of times a loop executes is often referred to as a counter variable. So I'm just going to kind of give this a semi-formal name. Right, count is a counter variable. X, we ultimately used it like it's a counter variable. Number was a counter variable in sum 100. While any valid user-defined symbol works as a name for a counter variable, programmers often name their counter variable I, short for iterator or iteration, something like that. Later on, we're going to see it used as like index, and that also works there. So the only reason why I'm even talking about this is ultimately a convention. I try to stress, using good variable names. X and Y maybe is not a great example of that, but having good variable names helps a lot with readability. Having I kind of goes against that rule of thumb. However, this is such a widely used convention that it is incredibly acceptable to just use I as your counter variable. Earlier, this was count, but it was a counter variable. So we could easily replace that with I, and no respectable programmer is going to bat an eye. No pun intended. Counter variables have one main purpose: counting iterations. That being said, it's perfectly okay to use them in calculations and even alter their starting values, right? This is sum 100. Instead of number, I could use I, but I want you to notice that I'm using I as a part of a calculation. So the main purpose for these counter variables is to kind of keep track of iterations, have control over the number of iterations that your loop, makes. However, it's perfectly okay to use them in calculations, which is what we're doing here. Counter variables are so common that an alternate loop, the for loop, which we're going to learn about later in this unit, directly implements the counter variable into its header. More on those later. Equally common is the need to update variables inside the body of a loop by updating the variable's value based on its old value. So right here, we're updating sum. The new value for sum is based on its old value. We're updating I here. The new value for I is based on its old value. Java and most modern day programming languages have included several shorthand assignment operators, which can be used to perform these frequently used equations. Let's take a look at plus equals, right? An example of it in context would be x plus equals y. Well, if I was to expand that, this is the same thing as saying that x is equal to what it was plus y. Minus equals, this is the same thing as saying x minus equals y. Careful on this one because order does matter, right? When we're talking subtraction, the order definitely matters. Multiplication, and we even have one all the way down here for mod. Okay, let's kind of implement those into our current program. I'm going to jump to sum xy. And here we have one of those situations. I'm updating sum to be based on the old value plus something else. Well, this can simply be rewritten. I'm going to leave it as a comment, but this is the same thing as saying sum plus equals x. Likewise here, this is the same thing as saying, leave it as a comment, same thing as saying x plus equals 1. So that's the little shorthand assignment operator. With those in mind, what is printed by the following code segment? Okay, we're going to take x. It is going to be what it currently is, which is 0 plus 3. We'll save that back in. The new value of x is 3. So when I get down here, what we're really saying is x is equal to x times 8, or 3 times 8 in this case. That's going to be 24. So when I get down here, we're saying x divide equals 2. That's the same thing as saying x is equal to x divided by 2. X at this moment is 24, so when we divide that by 2, we should get 12. Okay, here's another one. I'll give you a moment. Original value of x is 7. So this is the same thing as saying 7, well, x is equal to 7 times 3. The new value of x at this point is 21. So when I get down here, we're working with 21, but we're going to update it. What we're really saying is x is going to be equal to 21 minus 5. So when we get down here, we're working with 16. So we're going to update x. It's going to be 16 mod 2. Well, 2 goes into 16 an even number of times. There is no remainder. We would have 0 being saved back into x, and that's ultimately what we would print. Okay, while these shorthand assignment operators can be used on their own, right, as we've done with this math stuff, they are really designed to be used in the body of loops, right? We just switched these in our sum xy, and we could do something similar here in sum 100. These are just addition. This would be the same thing as saying sum plus equals number. This is the same thing as saying that number plus equals 1. I should probably comment that one out. So I did some, we're doing some math here with these things, but that's not very useful. That's really not what their intended purpose is. Their intended purpose is to do something like this and kind of make your code a little bit more concise. While these assignment operators can be used to write more concise code, you should be careful when using them as they are prone to error. Let me show you an example. Over here, I'm using a shorthand assignment operator, and if I were to expand it, it should be this, and it is, right, if you were to expand it. However, if we were to assign values and then actually see what the result is, we're going to see that we're getting different things. Here on the left-hand side, where I'm using the shorthand assignment operator, I get 10. And if I do it over here on the right-hand side, I'm getting 8. Okay? So be careful with these things. This discrepancy arises because assignment operators actually have the lowest precedence. Okay, here's our precedence chart of the important ones that we're hitting. Grouping, it's the highest. It needs to be the highest so that you, the programmer, can tell what sections of code you want to execute. Our method selector next, not surprisingly pretty high. We get into our math stuff. Relational operators are pretty low. A reminder that and has a higher precedence than or. And at the very bottom is the assignment operators. Now think about this for a moment. The whole purpose of the assignment operator is to give your variable a new value. Well, you want to basically do all of your calculations first and then assign it to the variable. So that makes sense that assignment operators are low. What's kind of quirky and different is that we have these math operations, right? These arithmetic operators that are tied to these assignment operators. Well, the fact that they're tied to these assignment operators, it's going to lower their precedence all the way down to that of an assignment operator. And that's what's actually kind of weird. So when we take a look at this, in theory, if we were to expand it, right? If it were expanded, the multiplication would happen first, then the addition. But because assignment operators actually have a lower level precedence than our addition, we would do this first and then save it in. Okay. This example reveals why you should show caution when using shorthand assignment operators. The process, my rule of thumb is like only use it on like 2 operands. Right here, I'm into like 3 operands. I probably wouldn't do a shorthand assignment operator. To be fair, this type of equation just happens so rarely that you probably just won't ever really encounter the situation. But just be mindful that that is what is happening. Our assignment operators have a extremely low level of precedence. Realities are most of the time you're using well, that's technically 2 operands, right? The variable itself, because ultimately these things are expanded. That's what these shorthand assignment operators are meant to be used on, is when you got 2 operands and it's just a simple arithmetic equation with 1 operator. Okay, tidying up some things. The process of increasing or decreasing a value by 1 occurs so frequently that 2 additional assignment operators exist to handle these scenarios. The operator here is plus plus or minus minus. An example of its use is saying x plus plus. That is the exact same thing as saying x is equal to what it was plus 1. Likewise, the minus minus, an example of that would be x minus minus. That is the exact same thing as saying x is equal to what it was minus 1. Okay, what that means is here I'm taking a look at sum 100, and I have these shorthand assignment operators, but this final one here where I'm just increasing I by 1, increasing or decreasing a value by 1 happens so often that we have yet another assignment operator to make this a little bit more concise, and that is I++. Okay, I'm going to flip back to my code and translate these guys. Right, this x plus equals 1, you could write it that way, you could fully expand it, but it's the same thing as saying just simply x++. I'm even going to leave both of these as a comment. Right, all 3 of these are the exact same. We're just increasing x by 1. Likewise, in my sum 100, here I'm increasing number by 1. I could simply say number plus plus. Okay. This syntax, this plus plus operator, gets used all of the time, right? I would rarely see this. If you're doing this, it's kind of an indicator that you're kind of a novice. Because the plus plus operator, it's so clean and this happens so frequently that this is what people kind of do in practice, which, by the way, this is where the notion of C++ comes from, right? There's a programming language called C, and then there is, of course, C++, right? So this is basically saying this is one more version or iteration better than C. Likewise, and I'm very proud of myself because I recognize this on my own, there's a programming language called C#, developed by Microsoft as their version of Java. But what I want you to notice about this is C++++. Hornet's big brain. All right, that's going to be it for this one. I'll see you on the next one.